Alright, 4-4, so we're going to take our matrices and use them for some geometry here today. Geometric transformations with matrices, that's 4-4. So, getting started, a little preview here, we're going to learn to represent translations and dilations with matrices. If you remember back, translations is moving and dilations is making things bigger or smaller. Alright, and then we're also going to represent reflections, so that's flipping, and rotations, that's spinning around, also with matrices. Alright, so a bunch of words here, phrases that we're going to need to use. Transformation, image, pre-image, translation, dilation, reflection, rotation, and center of rotation are our vocab for this lesson. So let's get started. Skills that we're going to need. I'm going to do one for you. You guys will do the rest. And so it says we want to graph the original shape, whatever it is. And so the first one, y equals x plus 2. I would go up 2, make a dot. My slope is 1, so I'd go up 1 and over 1, make another dot, connect it, and I've got myself a nice straight line. And then it says I want to go left by 4 units. So on this one, I could go 1, 2, 3, 4. So this dot here gets moved over 1, 2, 3, 4 units over, and this dot here 1, 2, 3, 4 units over. I've just translated that line left by 4. All right, so take a few minutes, pause the video. Your job 2 through 6. Okay, so I'm not going to have you go through this whole thing, but just in your textbook it has this, which is a nice kind of explanation of what we're up to this chapter. If we have this shape, right, this nice little Tetris piece here, and we wanted to take it 4 units right and 6 units down, we could take each corner and move the corner 4 units right and 6 units down. And if we did that with all the vertices, we would be able to do this without having to use the graph paper at all. We could do it just by looking at the numbers of the vertices and how much we're going to move them. And so we can see that right here with this example. So here's the shape. We've got 4 vertices. A is 0, 0. B is negative 1, 4. C is negative 4, 2. And D is negative 4, 0. And we're going to go ahead and write this in a matrix, A, B, C, D, with an X and a Y coordinate. Alright, so a couple vocab before we keep moving. A transformation is a change we make to the figure, keeping it the same size. So just moving it sideways, just moving it up and down. Any image, any shape we're going to call an image. The before is the pre-image, okay, and then the translation is what takes us to the new image. So let's look at an example. Here's our first shape. It had points at 0, 0. It's the same one that we looked at before. We want to move this 6 units right and 2 units down. So we're going to have this translation matrix here. X's are the top line, so we're going to go right 6. Y's are the bottom line, so we're going to go down 2, negative 2. We're going to do that to every single point, A, B, C, and D. And we don't have to actually draw them or move them. We can say, okay, what's 0 plus 6? 6. What's 0 minus 2? Negative 2. Go all the way across. What's negative 4 plus 6? Positive 2. And if we were to plot these as 4 new points, here they are. A is now 6, negative 2. That's what this point is. B is now 5, comma 2. That's what this point is. Same with C and same with D. And these little tick marks, we're going to call these prime. So A prime, B prime, C prime, and D prime. All right, so our new image is over here. A prime, B prime, C prime, and D prime. It's been moved over 6 and down 2 from our pre-image of A, B, C, D. Okay, and when I say moved, it's been translated. Translate is the word we want to use. All right, so take a second, see if you can use what we just did to answer 1A, B, and C. All right, so we've done translations. Now let's talk about dilations. And a dilation is when we're going to multiply every single point, either bigger or smaller. So what we're doing here is scalar multiplication. All right, so we've got this picture of a tiger. Or is that a lion? Doesn't say. I guess this would be a lion, right? No mane on it. Anyway, or no, tiger. Tiger has no mane. Is this what we are, or are we lines? I can never tell the difference. Anyway, write a matrix to represent the coordinates of the vertices, which are given here. 0, 0 is the bottom corner, then 0, 5.875, which is over here. And we want to multiply it by a factor of 1.2. Just scalar multiplication. We're going to take every single point and multiply it by 1.2. So 9.75 times 1.2 turns into 11.7. And so we have our new coordinates. If this was to stretch out further, okay, 0, 0 wouldn't go anywhere. It would still be here, but if we stretched it out from there, we would have these as our new points. See if you can use that kind of thinking to do some dilation on understanding check number 2. Alright, so now we're going to reflect. We're going to flip either over the x or over the y, or maybe over the lines y equals x, which is, remember, is the diagonal line, 45, or y equals negative x, which is the negative line running down. Alright, so you're going to want to put these in your notes. These are the matrices that will reflect us on each of these. Reflection in the y, in the x, over the line y equals x, and over the line y equals negative x. If you have those down, pause it if you don't, but if you have those down, here's how we can reflect a shape, an image, without having to do it graphically. We could do it straight from our matrix. We want to take this shape with these coordinates, 0, 0, 2, 5, negative 2, 3, about the y-axis. So we're going to go back and grab our y-axis matrix, which is this one, and multiply them together. If we do that, here's our new coordinates. And you'll notice here that all of the y values stayed the same, right? We didn't flip over the x-axis, but all the x values changed to a negative. 2 to negative 2 and negative 2 to 2. So it's just flipped horizontally. And so you can see the same thing is going on here for B, C, and D. Do some matrix multiplication and we'll get the coordinates for the vertices of our new image. So your job here is to do some reflection for the shape made by these 3 vertices. Alright, last thing we need to do is rotate, and when we rotate, we got to know where we're rotating about. So we have to have some center of rotation, okay? And the most we can spin is 360, because after that we're just spinning around and around again more than once. So we only care about from 0 to 360. We have some nice matrices that are pre-figured out for rotating 90, 180, 270, and 360 degrees. So you want these in your notes, pause it until you've got those, and then move on to example 4. If we take this shape and rotate it 90 degrees, we have to grab our 90-degree matrix. We're going to multiply it. We'll end up with these as our new vertices. And notice what's going on. 0, 0 doesn't change, but 2, 5 changes to negative 5, 2. We're going to switch them, and the x's become negative. We're going to switch them, and then the x becomes negative. It used to be positive 3, now it's negative 3. Whereas the y value, the new y is negative 2, just stays negative 2. Okay? You'll see that for all of these. This rotated 90 degrees, this rotated around 180 degrees, and you'll see all the way down. 360, we ended up where we started, right? So that's basically not moving at all. Your turn. Finish this up. Number 4, understanding check. And any questions, we'll go over it in class.